Since the James Webb Space Telescope launched, scientists have been running wild trying to capture images of everything they can within the universe. From the internet-breaking image of the deep field to the almost terrifying image of the pillars of creation, it has surpassed our expectations in every sense of the word. So, it only makes sense that they're looking for more. In fact, they're looking to photograph exoplanets to learn more about what they are and whether life may exist on them. Join us as we learn more about attaining a clear image of one such Earth-like planet, Proxima B. So let's get right to it. Ever wondered if there's life beyond our solar system? Well, scientists have recently discovered a planet that could potentially support life, and it's closer than you might think. Proxima B is a planet orbiting a star called Proxima Centauri, which is the closest star to our Sun. This planet is similar in size to Earth and orbits within what is known as the habitable zone, where conditions could be just right to support liquid water and perhaps life as we know it. What makes Proxima B so exciting is its proximity to our planet. It's only 4 light-years away. That might sound like a lot, but in space terms, it's like having your next-door neighbor host a party and invite you over. We're practically neighbors. The star that Proxima B orbits, Proxima Centauri, is a red dwarf that's smaller and cooler than our Sun. And while Proxima B is closer to its star than Mercury is to the Sun, its host star's cooler temperature means that it still falls within the habitable zone. Scientists believe that only one side of Proxima B faces its star, just like only one side of our moon faces Earth. But that doesn't mean the other side is completely uninhabitable. Who knows what could be hiding on the other side of this mysterious exoplanet? Overall, Proxima B is an incredible discovery that brings us one step closer to unraveling the mysteries of the universe. The fact that it's so close to us makes it that much more intriguing. Who knows what else is waiting to be discovered? When it comes to finding planets with the potential for life, scientists need to consider a whole bunch of factors. Remember, just because a planet is in a star's habitable zone doesn't necessarily mean it can actually support life. It simply means the planet has temperatures that could sustain liquid water, a key ingredient for life as we know it. But that's not all. For a planet to be considered truly habitable, its host star needs to burn for long enough to allow life to evolve, and it must emit appropriate amounts of ultraviolet radiation. That's where Proxima B comes in. Not only is it the closest of the 44 potential habitable exoplanets we've discovered so far, but it also has the highest Earth Similarity Index, ESI. ESI is simply a way to measure how similar a planet is to our home. The closer the ESI is to 1.0, the more similar the planet is to Earth when it comes to its size, density, and surface temperature. And now, thanks to the James Webb Telescope, we may be close to finally attaining the clearest image of Proxima B ever. It's very difficult at this time to see much detail since the planet is very close to its star and basically hidden from view. But who knows what we might discover in the future. For now, let's just keep in awe of this fascinating exoplanet and all that it represents. Now, we've never actually seen Proxima B up close because it's about 4.2 light-years away from us. But scientists have been able to observe changes in Proxima Centauri's color, which has led them to believe that Proxima B is there, right where it should be. Proxima B is a pretty interesting planet because it's tidally locked to its star. That means one side of the planet always faces the star, and the other side is always in darkness. Even though it's really close to its star, it's not as hot as you might expect because Proxima Centauri is a red dwarf star, which is cooler than our Sun. Did you know that the way land is distributed on an exoplanet could have a big impact on its climate and potential habitability? That's what a group led by climate scientist Dorian Paradise MacDonald has found. See, when a planet is tidally locked to its star, one side is always facing the star and experiencing intense heat, while the other side is perpetually in darkness and freezing cold. Not exactly the most hospitable conditions for life as we know it. But there's hope. MacDonald's team wanted to see if the amount and distribution of land on the day side of a planet could make it more habitable. They ran simulations comparing a planet with a circular continent in the middle of a liquid ocean to one with a circle of land surrounded by ice. And what did they find? Well, more land on the day side meant less rain, higher temperatures, and a bigger difference in temperature between the day side and night side. But if there was more ocean, there would be more rain and clouds. And get this, even if the total amount of land stayed the same, The way it was distributed could cause the average surface temperature of the planet to vary by as much as 20 degrees Celsius. That's a pretty substantial difference. What does this all mean? Let me break it down for you. The discovery of each exoplanet has taught us that these celestial bodies are much more diverse than we previously assumed. Thanks to this realization, we also have some insight into how scientists can improve our search for other habitable planets outside our solar system. But coming back to Proxima B, there is a good enough chance that it could support life, mainly because scientists believe it may have water and an atmosphere to shield it from extreme heat. But we can't be sure yet, not unless we get some concrete evidence. That's where NASA's James Webb Space Telescope comes into play. This telescope specializes in observing infrared light, which is super important when it comes to studying planets like Proxima B. How does this work, you ask? If Proxima B has an atmosphere, it would absorb light from its star and release it as infrared light instead. And the JWST is just what we need to detect it. By taking photos of infrared light on Proxima B, scientists can search for patterns that would indicate whether or not the planet has water or is covered by an atmosphere. So, even though we don't have concrete evidence that Proxima B is an Earth twin, we're inching closer to finding out thanks to some incredible technology. As is usually the case with space exploration, things aren't so simple. The proposed method may be the best option out there, but there are other factors that need to be considered. For instance, even the existence of an atmosphere is not sufficient to guarantee that life may exist, says astrophysicist Ed Turner of Princeton University. It is also possible that Proxima B may resemble Venus with an atmosphere that is 90 times thicker than Earth and extreme heat. Still, hope remains that Proxima B could be a potential candidate to help us learn more about the Earth next door. The reason we're so sure is that the JWST has managed to photograph another exoplanet. Get this, the James Webb Space Telescope, also known as the JWST, has just captured its first images of a planet orbiting a distant star. The planet, HIP 65426b, might not sound like a superstar, but it's actually a gas giant that's several times more massive than Jupiter and only 15 million years old. That's like a newborn baby in astronomical terms. But wait, it gets better. The planet is roughly 350 light-years from Earth. Talk about long-distance relationships. Now, I know you might not be too impressed by how detailed these new planetary images are, but the researchers who were able to take the images certainly were. When the results came back, Sasha Hinckley, an astrophysics professor at the University of Exeter in England who helped lead the study, said, "I had to make sure that I wasn't looking at a simulated image. It looked like the model images from when we wrote our proposal 5 years ago. But let us tell you, the JWST images of HIP 65426b revealed that it is outperforming expectations for its exoplanet studies. And this is good news because this also means that JWST's planned endeavors to observe other exoplanets will probably be even more successful than researchers had hoped. And that's great news because astronomers can now get even more ambitious when they submit proposals to JWST's governing board in the upcoming research cycles. The possibilities are endless. So let's give a round of applause to the amazing team behind JWST who have managed to achieve the seemingly impossible feat of taking direct photographs of exoplanets. As Sasha Hinckley puts it, "Yeah, I was really intrigued by the technical challenges of this research, of having to block out these super bright host stars which are 10,000 or a million times brighter than the faint planets orbiting them. It almost sounds impossible, like trying to spot a tiny glowing firefly fluttering under a bright stadium light from your seat across the field. But with the right technique, exoplanets can be revealed, and we're only just scratching the surface. Exciting times are ahead in the field of exoplanet research. The James Webb Space Telescope, JWST, just took some direct images of a giant gas planet called HIP 65426b. It's a real baby, only 15 million years old, and it's hanging out about 350 light-years from Earth. Now, you might think, big deal, we've seen plenty of pictures of planets before. But hold on, this is different. The researchers are super excited about these images because they show that JWST is way better at studying exoplanets than they originally thought. Sasha Hinckley, an astrophysics professor at the University of Exeter in England who led the study, said that when the results came back, they looked like something out of a simulation model, not real life. But they were real, and that's a big deal. You see, Observing planets outside our solar system is no easy feat. These host stars are insanely bright, think 10,000 to 1,000,000 times brighter than the planets they're orbiting. Imagine trying to spot a tiny glowing firefly fluttering under a bright stadium light from across the field. That's the challenge the team was up against, and they nailed it. This success means astronomers can get even more ambitious when they submit proposals for future studies with the JWST. Who knows what other amazing discoveries are just around the corner? With the JWST paving the way, we're in for some exciting times in the field of exoplanet research. This is huge news because it means that the JWST is way better at observing planets than we initially thought. So, it's no surprise that Sasha Hinckley, an astrophysics professor at the University of Exeter in England who helped lead the study, was absolutely amazed when the results came back. He said he had to make sure he wasn't looking at a simulated image because it looked just like the model images from when they wrote their proposal 5 years ago. The fact that the JWST has managed to capture direct photographs of HIP 65426b, a gas giant that's about 7 times larger than Jupiter and 350 light-years away, is an incredible achievement. It's no wonder the researchers are so excited. This breakthrough means that the JWST is outperforming expectations for its exoplanet studies. It also means that astronomers can now be even more ambitious when they submit proposals to the JWST governing board in the upcoming research cycles. The sky's the limit. So, let's give a round of applause to the amazing team behind the JWST for achieving this seemingly impossible feat, as Sasha Hinckley puts it. Yeah, I was really intrigued by the technical challenges of this research, of having to block out these super bright host stars which are 10,000 or 1,000,000 times brighter than the faint planets orbiting them. It almost sounds impossible, like trying to spot a tiny glowing firefly fluttering under a bright stadium light from your seat across the field. But with the right technique, exoplanets can be revealed, and we're only just scratching the surface. Exciting times are ahead in the field of exoplanet research.